Welcome to the sixth and final segment of the systems documentation tutorial. Perhaps you share my sorrow that the tutorial is ending soon. If so, I invite you to start at the beginning. Go back to segment 1, click play, and I would be happy to repeat everything I've said thus far. If not, then hold on for the ride, because here we go. Systems flowcharts are potentially the most complex and detailed diagram we will encounter in this tutorial. That doesn't necessarily mean that they are the hardest to create. The purpose of a systems flowchart is to capture the flow of documents through the system and show who is responsible for performing the different activities in the system. This means several things. First, let's tie it back to our data flow diagrams. A physical data flow diagram captures the flow of information between entities, people or things, but does not tell us what those entities do. While a logical data flow diagram captures the flow of information between activities, but does not necessarily tell us who or what does them. A flowchart brings them together, showing us who does what. It does this from an entire system view, highlighting how the parts of the system interact to complete the process. A systems flowchart also displays more details about system implementation. For instance, whether a data store is an electronic disk or paper file is irrelevant in data flow diagrams, but we can specify this detail on systems flowcharts. Likewise, a process, whether it's computerized or manual, that is performed by a human, is something that we can detail on a systems flowchart. Before we jump into creating the actual diagram, let's introduce you to the common flowchart symbols. Systems documenters meet flowchart symbols. Flowchart symbols meet system documenters. Now, I think y'all are going to get along just fine, but let's introduce you in a little more detail. You can roughly categorize the flowchart symbols into 6 groups, 5 of which you see here. The flow symbols are used both to illustrate the flow of information as well as the sequential ordering of processes in the system. For instance, the document symbol represents documents being passed around. While a document can take on an electronic form, we will usually use the document symbol to represent paper documents. This is all context specific. The batch total symbol represents a single number that flows with a set of documents. The logical flow symbol is often used in conjunction with the document symbol, but is often used to create a dependency between 2 processes, meaning one process cannot begin until the other process ends. So regardless of whether you have a document symbol associated with the flow, with the arrow always creates a dependency, meaning that one process can't proceed until the other process is ended. This is very similar to data flow diagrams. The same condition held there. There are 2 main types of processes, the manual process and the computerized process. The manual process is performed by humans, and the computerized process is, that's right, you guessed it, performed by computers. The I/O or input-output symbols are used to interface with computerized processes, showing what data is input and what data is output from the computer. The manual keying symbol, I call it the keyboard symbol, represents how humans type data into the computer. It reminds me of an iPad with its cover folded back behind it. They have the same shape. Now the display symbol looks like the old tube monitors back before flat screens. So hopefully you still remember those, and it's just how the computer displays information to the user. And then moving over, the data store symbols are different from DFDs in that they have more specificity. The triangle represents a paper-based store, like a filing cabinet, or, heaven forbid, a stack of papers on somebody's desk. And the cylinder represents an electronic disk, like a hard disk drive. And then last but not least, we have the connector symbols. You have seen these used in your system understanding aid. They make your diagrams cleaner by allowing you to not have to connect symbols on different pages or opposite ends of the same page. Oftentimes, when you're trying to connect all these symbols together, you end up with a spaghetti diagram. And so using the on-page connector allows you to eliminate the spaghetti while still illustrating the flow. Now, in my humble opinion, the internal and external entity symbols are the most important. Why? Because if you can get these symbols correct right off the bat, meaning if you can diagram the internal and external entities correctly on the flowchart, you will have a nice skeleton diagram that will be easier to flesh out with the other symbols. I'll show you what I mean in a minute. But for the meantime, just know that every internal entity needs its own lane. I call them swim lanes. They divide the activities that are performed by the different internal entities. You don't want to diagram an entity as performing another entity's duties any more than you would want one swimmer swimming for another swimmer in competitive swimming. So every action that internal entity A performs should fall under its respective lane. External entities will be represented with this pill-shaped symbol. Notice that it's labeled as a start-stop symbol. This is appropriate given that external entities provide or receive all inputs or outputs to our process, so they serve as beginning and end points. Our process should begin with receiving something from an external entity and end with us sending something to an external entity. We'll also use this symbol to initiate time-triggered processes, such as those that begin, say, quote, at the end of the day, or, quote, every morning. Remember, you should have as many internal and external entities on your flowchart as you did on your DFDs. So if your physical data flow diagram has 3 internal entities, then start your flowchart by making 3 swim lanes. If your context diagram shows 2 external entities, then place 2 external entities on your flowchart. You can figure out where to connect them later. Just get them there as reminders that you need to connect these external entities into your flowchart. In fact, that's the first step we're going to take to create our flowchart. And that's why I think the entity symbols are most important in the creation of flowcharts. So let's go back to our physical data flow diagram and see what external entities we had in the Supreme Athletic Supply documentation. We had 4. We had the sales rep, the laptop, the headquarter computer, and the order entry clerk. So let's place those on our flowchart. Now it just so happens that these internal entities occupy the columns that we would like them to. A general rule of thumb is observe, go back to our entity activity table and observe what entity performs the most actions and give it the most space. Another rule of thumb is if you have 2 human entities that interact with a computer entity, place the computer entity in the middle. This will prevent you from having to cross needlessly a human entity's lane in order to interact with the computer. You'll see this in just a minute. Now, let's look at our context diagram. We could look at any of the DFDs really, but the context diagram's purpose is to establish the system boundary and therefore identify the external entities. So we go there. There are 2 external entities. So let's place 2 pill symbols here on our diagram. So we're off to a good start. At this point, it's really just a matter of following the narrative through in sequential order and diagramming what occurs and who or what performs it. So let's start doing that. If we look at our entity activity diagram, we can see that the first thing that happens is the customer gives the order to the sales rep. So the customer provides the order to the sales rep, and you can see that on a flow chart, the order falls under the sales rep. So we're diagramming the fact that the sales rep receives that order. What does the sales rep do with it? Well, item number 2 here says that the sales rep enters the order into the laptop. And how are they going to enter it into the laptop? They're going to use our keyboard symbol. And on this keyboard symbol, we're going to use an action phrase. So we're going to say enter customer order. That's descriptive of what's going on while we're interacting with the computer. Then we'll connect that. And then that customer order flows to the laptop. I'm going to make a little room here. It flows to the laptop. Now here's a general rule. A laptop always requires a process to store or retrieve information. So we're going to place a computerized process there and label it as save customer order. We'll borrow one of these logical flows and connect it. Now where are we going to save it? We're going to save it on the laptop's disk. And then item 4, it says the laptop prints 2 copies of the customer order. So let's not create a separate process. We could say save and print customer order. And so one output of this will be copies of the customer order. And we could specify it as printed order. And we'll go ahead and call it customer order and be consistent up here. And call that customer order as well, because we're going to distinguish that from a sales order later on. Now I'm going to make a copy of this and blank out the text just so I can stack these orders on top of one another. Then we're going to show these 2 documents as an output from that save and print customer order. And then it tells us in item 5 that the sales rep gives customer order copy 1 to the customer and files customer order copy 2. So let's display that. Now at this point the sales rep is done. And so if we look at number 7, we see that at the end of the day, the laptop retrieves the daily orders and sends them to the headquarters computer. So as I mentioned previously, we often use the start and stop symbol to illustrate time-triggered processes. We're going to do that here. So in order to send them, it has to retrieve them. So we'll show it retrieving them from the daily orders. And then it's going to send it over here to the headquarter computer. But to keep our diagram a little cleaner, we're going to leverage this on-page connector. And how does it send them? It sends them to the headquarters computer probably through a network. So we're going to use this communication link symbol. We'll label our on-page connector as A. Then we'll copy that. Now if we return to our table, we see that the headquarter computer calculates various totals and records the totals and orders in the customer order file. Then let's go back to our table. Number 11 says, each morning the headquarter computer displays the customer order file with totals to the order entry clerk. Then if we look back at number 12, the order entry clerk reviews the orders, compares each sales rep's totals with the totals provided by the customer, and notifies the headquarter computer to proceed. So let's go over here and get our manual process. And we're just going to clump those few activities together because the order entry clerk does them together. So can you see that we're illustrating that the customer orders information serves as an input to this manual process? And then we're going to notify the headquarter computer to proceed. And how do we notify it? How would the order entry clerk notify it? Probably through a press of a key or a button. So let's borrow this keyboard symbol. And just because I'm an anal diagrammer, I am going to rotate it. Rotate shapes, flip horizontally. There we go, and this notification is going to be a form of information telling the headquarter computer to proceed. So we'll put that there. And when it does proceed, the headquarter computer is going to perform a series of program edits. Again, that's not very useful. But 16 says, validates customer name and address with the customer master file, checks customer credit limit with the customer master file against the order amount, outstanding sales orders from the sales order master file, and the accounts receivable. So it's doing a lot of validating here, but what's key is where it's getting this information. So the process we could name validate customer info and check inventory and credit limit. Now again, you could separate these out into separate processes, but they're all being done at the same time with the computer, so I put them together. But what's going to be key is we've got several data stores that we're going to need in order to complete this process. So the first one is, if we're going to validate customer info, we need the customer master data. What did we call it? Here we have customer master, so we'll call it customer master there. We will also need to check the inventory, so we're going to need to draw from the inventory master. And we're going to be checking credit limits against accounts receivable, so we'll call this accounts receivable master. And we need one more because it tells us that we're going to check the order amount against outstanding sales orders, which would come from the sales order master. Now I'll just connect these all with flows. So the next thing that happens is it records the customer order in the sales order master file, reduces the inventory balances, and prints 2 copies of the sales order. So these are all related in that we're recording the sale. So we're going to put them together. Record customer order, reduce inventory, and print sales order, which we're distinguishing from the customer order. So interestingly here, we may actually move these up just because we're going to be connecting to them. When we record the customer order, we're going to be updating the sales order master. So we'll take this and show that we're updating sales order master. We're going to be reducing inventory. And then we're also going to hit the accounts receivable. If we record the customer order, part of that is to update accounts receivable. But then it also prints 2 copies of the sales order. And one of them goes to the warehouse as a picking ticket, and the other goes to the customer. So in closing, let's review some of the tips that we have when we're creating flowcharts. First, we want to create a swim lane for every internal entity. If you do that, then you've got the basic structure of your flowchart. Swim lanes are necessary. I've seen students leave them out and they get docked. The second is we want to keep computerized processes in the swim lanes of computer entities and manual processes in the swim lanes of human entities. And related to this, the I/O symbols will always fall in the human entity swim lanes because it's what the humans use to interface with the computer. So the display and the keyboard will fall under human entities. Coming back to this third bullet, a computer is the one that must access electronic data stores, meaning disks usually, or tapes. So the cylinder should not appear in a human entity swim lane, and there should always be a process in the computer's lane that shows that it's retrieving information. A computer just can't reach in without performing some process to access an electronic data store. So that concludes our last segment of this tutorial where we've shown you how to create flowcharts. So if you've made it this far, you've got a really good grasp on how to do systems documentation. It should be noted that there are other types of documentation, but in this course we're just focusing on data flow diagrams and systems flowcharts. In general though, if you can document a system in a graphical form, it serves as a great communication tool with you and your client, or you and a coworker, you and management, and it creates this medium where you can hash out the details of the processes. And I would submit to you that you really don't understand the process until you can diagram it in a graphical form. And so for that reason, it is worth it to document it with these symbols. A lot of people will use narratives out in practice just because it's fast and easy, and their firm can't justify the time to do systems documentation. But if you can think in this manner, you will be ahead of the game because you'll be able to think in an abstract manner and be able to apply that to your real practice in accounting. So I hope you've enjoyed these tutorials. It's been fun having you. I hope that you pass this on to those that you think might enjoy it and benefit from it. So with that, this is the last and final tutorial, and with sadness, we conclude.